Today, we're going to go through the properties of ionic and covalent compounds. I am your instructor, Arthur Jibondo, and this is from 3 Chemistry. Okay, today's lesson is really about things that you use almost every day, right? We will talk about salt, sugar, right? You use these things almost every day. Magomomu, salt, kapena sugar, wailovu, ndosasowa kwenikweni. But in this lesson, I want to pose you with a question. And this question, I think it is important because if you are able to answer it at the end of this lesson, it's honest that you have managed to understand what I have told you. But if you are not able to answer this question by the end of this lesson, it will mean that you have not understood. So by the end of this lesson, I expect you should be able to answer this question. Sugar solution is a non-electrolyte, while a sodium chloride solution is an electrolyte. Explain. I actually got this question from the review exercises in your book, in your Form 3 book. So that is literally a question that an examiner would pick for your exams. So you need to be able to answer such a question by the end of this lesson. I'll just try to elaborate a little bit. Tikati electrolyte, good electrolyte and the an electrolyte ili ngati solution yoti imapanga allow electric current to pass through it, right? Yeah, so they're saying sugar is an electrolyte, trying to mean similar electric current to pass through it, while sodium chloride is an electrolyte, meaning imalola electric current to pass through it. Why is that the case? So you should be able to answer that question. Now, let's go back to Form 2 chemistry. In Form 2, you learned about chemical bonding, right? You learned that there are several types of chemical bonding, including ionic bonding, covalent bonding, and metallic bonding, right? So now I want us to have a recap. Tuone kuti tinkati chani, right? We said that ionic bonding happens when a metal atom transfers electrons to a non-metal atom. That was basically what ionic bonding is. Now, what happens in ionic bonding is that as an electron is transferred from one metallic atom to the non-metallic atom, there is a change in the net charge in the atoms, right? What I'm trying to mean there is that you understand how atoms amakhala kuti ali neutral, right? Amakhala kuti ali ndi ma electrons komanso ma protons ofanana, right? Now, when you are taking an electron which is a negative charge from an atom, it means it's ndi ma positive charges ambiri. That makes that atom, that remains of that atom to be a positive ion. Pamene atom imene ikulandira electron ija imakhala kuti yalandirano ma negative charges, ili ma negative charges ino ambiri kuyerekeza ndi ma positive charges. That's why the recipient of the electron becomes a negative ion. This is literally what happens in ionic bonding. Now, because one atom has lost an electron and the other has gained an electron, and there is a positive and a negative charge in that solution, they are now attracting each other to form a compound. And that compound that is formed, it is formed thanks to an ionic bond between those positive and negative charges. A good example is how sodium chloride is formed. Sodium chloride, of course, it's also known as table salt, kitchen salt, amino magomo. What happens here is that sodium ama lose electron imene ili in its outermost shell, and chlorine amapanga receive that electron imene yachoka kwa sodium kuti akwanise 8 electrons in its outermost shell. That's how ionic bonding occurs. Yeah. Now, let's proceed to review what covalent bonding is. Covalent bonding is when two non-metal atoms share electrons so that each can have a full outer shell, right? So this is something that should help you to differentiate covalent and ionic bonding. You have to remember that in ionic bonding, we have a metal, right? Whereas in covalent bonding, we have two or more nanometers. That's the difference between the two. So if you have 2 nanometers and these nanometers want to bond, the type of bonding that is going to take place is covalent bonding. And with covalent bonding, the bonding happens in the outermost electron, in the outermost energy levels, given outermost shells of the atoms. So they so the electrons are shared so that each shell has 8 electrons. A good example of covalent bonding is the bonding between hydrogen and oxygen to form water, the bonding between oxygen atoms to form oxygen gas, the bonding between chloride atoms to form chlorine gas, right? So what is happening in each of these scenarios is that these 2 nanometer atoms, they are sharing these electrons so that each atom, if you count, they have 8 electrons in the outermost energy level. So that is the essence of covalent bonding. Now, let me proceed to metallic bonding. Now, you learned that metallic bonding happens when metal atoms, right, they share their outer electrons freely so that the electrons move in what is called a sea of electrons. You could just remember a sea of electrons when you want to ask a question about metallic bonding, right? Metallic bonding is what holds the metal atoms tightly together to form the firm solids that metals are. They have a strong metallic bond between them. Now, examples of metals that exhibit this type of bonding, limonga, iron, aluminium, copper, just to mention but a few. And it is actually this sea of electrons, many mabangisa kuti ma-metals akhale ngati ma-good conductors of electricity, because remember, for there to be electric current, there must be my charge carriers. There must be my particles to make electric current from one point to another. Now, these electrons in metals, that that electricity should flow in the circuit. Now, we have actually done a recap of ionic bonding between a metal and a nanometal, covalent bonding between 2 nanometers, and we have done metallic bonding, where metal atoms share their outer electrons to form a metallic bond, right? So I'm going to proceed to discuss the main topic lesson here, which is the properties of both ionic and covalent compounds. So, ionic compounds, the first property is that ionic compounds are electrolytes. And as you can remember, my electrolytes in the solutions amapanga conduct electricity. Kaudi electric current has been passed through them, imadusa bino ndikupanga complete circuit, right? So, for ionic compounds, they conduct electricity when they have been dissolved in a solvent that may be water, they have been diluted, or in molten state when they have been like maybe pamoto ndikupanga melt to their from solid to liquid state, they can conduct electricity. Another property that you should know about ionic compounds is that they have a high melting and boiling point. So this means pamafunika got a large amount of heat energy to change from solid to liquid, that is the melting process, and from liquid to gas, that is the boiling process. So these ionic compounds, they require a large amount of energy for that to happen. And their structure has a lot to do with these properties. The other notable characteristic of ionic compounds is that they're generally soluble in water, meaning when you put an ionic compound in water, it dissociates. By dissociating, tikutanthauza kuti zimapanga break down into its ngati my main components, right? For example, if you put sodium chloride in water, what happens is that sodium chloride amapanga break down into sodium ions and chloride ions. So that is what it means to be soluble in water. Another characteristic is that ionic compounds are insoluble in organic solvents like benzene or propanol. Now, we have just discussed the zikupanga dissolve in water. But what if you took, for example, mafuta, ndiwikamo mchere, or you could try that if you are okay, or you could try that if you want to try it out. Mutenge mafuta mwikemo ka table salt kapena mchere wa kitchen uja. You will notice that no matter how hard you stir, mchere ujasungasungunuke mafuta. But when you take it in water, it's going to be soluble. So that's what it means. It is insoluble in organic solvent. Mafuta is an example of organic solvent, whereas it is very soluble in water because of what we're going to discuss also about polarity of these compounds. Water being a polar compound dissolves polar compounds, which are ionic compounds. Okay, another characteristic that you cannot miss about ionic compounds is that they have a crystalline nature. And what I mean by crystalline, they form crystals, right? Crystals lingati michele kamena timibulu, and these crystals are very brittle. A good example, I like to give example of salt, table salt, or especially kitchen salt, which is the big crystal salt, right? That salt, when it was being manufactured, it was laid to dry and then it formed those crystals. But those crystals, when you look at them, if you can just grind them, or you could even grind that using your teeth. That's what it means to be brittle, right? Now let's proceed to properties of covalent compounds. One of the main properties of covalent compounds is that it does not conduct electricity. We discussed that ionic compounds conduct electricity. Ionic compounds such as sodium chloride or whatnot, they conduct electricity. But covalent compounds, they do not conduct electricity. And there's literally a reason for that. It's because they actually do not have free charge carriers. They do not have free electrons, right? So that is why they do not conduct electricity. They also have a low melting and boiling point. The bonds that form between these compounds are very, very weak. That is why there is literally a low amount of energy that is required to change from solid to liquid and from liquid to gas. And another hallmark characteristic of covalent compounds is that they are insoluble in water. It means when you put, for example, an example of a covalent compound would say what? Would say oil. Oil is an example of a covalent compound, right? When you take oil and put it in water, right? So that's what it means that it is insoluble in water. And they say most, it means there are some covalent compounds that actually dissolve in water. You will give an example, sugar. But of course, even sugar does not completely dissociate into its constituent components, of course, right? It only dissociates into its molecules as most covalent compounds. Now, most of them are gaseous or volatile liquids at room temperature and pressure. Unlike ionic compounds, amina solid at room temperature. Covalent compounds are gas, kavena, volatile, because they have weak intermolecular forces. Now, another thing is that they have a scent. Like that's when you know that this is a covalent compound. So examples of covalent compounds, we could talk of gases like sulfur or sugar, carbon, and organic solvents such as propane or ethanol. Wow, that is an example of a covalent compound. Okay, so we have discussed about ionic compounds. Takambira naso zama covalent compounds, and I've given you the properties. I'm a covalent, I'm a properties, I'm ionic compounds, and with those properties, I think you would be able to say compound iyi ndi mmene ikuonekera ikuonera kuti ma properties ake akuonesa kuti ndi ionic, ayi ndi covalent compound, right? Now, what if I ask you a question, right? What type of compound is diamond? Yes, diamond yemwe, this substance that is used kupanga ngati mwina ngati timalingi tobeba kubeba chani. You know diamond, right? What type of compound is it? Is it ionic or covalent? Now, I'll give you more clues. It is not liquid or gas at room temperature. No, it is a solid. And guess what? The melting point is a staggering 3,550 degrees Celsius. Right? What type of compound do you think diamond is? Anyway, I guess you guessed it is. I guess you guessed that it is covalent because it is actually a covalent compound. Only that diamond, graphite, they are an exception when it comes to this stuff. They are in their own elite club, right? Some covalent compounds, for example, diamond and graphite, have unusually high melting and boiling points. For example, diamond amapanga melt by 3,550 degrees Celsius, while graphite it actually melts at 3,730 degrees Celsius. That is unusually high and somehow way higher than my ionic compounds in monga na sodium chloride. I mean, amapanga melt at around 800 and something degrees Celsius. So it is somehow an exception. It is still a covalent compound, but it is an exception to the rules of covalent compounds. But if I may ask you, why do you think this is the case? Okay, maybe you'll be expecting but I'm not going to reveal the reason why diamond and graphite have these high boiling and melting points. No, I'm not going to tell you. Actually, I want you to take this as your homework. Find out on your own, and we will discuss in the next lesson, which is going to be about the structures of ionic and covalent compounds. Now, there are several experiments in this lesson, but we're going to only do one. Basically, I will not be doing it. I'll just show you a video that is going to help you to investigate the electrical conductivity of covalent and ionic compounds in solutions. Basically, you'll be testing the conductivity of sugar and salt, and at the end, you are going to see for yourself that salt will conduct electricity, whereas sugar will not conduct electricity. Now, we should get back to the first question that I posed before the start of this lesson. I posed a question asking, why do you think sugar doesn't conduct electricity? Like it's not an electrolyte, whereas sugar conducts electricity. But the thing is, salt conducts electricity because it dissociates into free ions which transfer electric current, whereas sugar does not have free ions when it dissociates in water. It instead dissociates into sugar molecules. So because they are neutral molecules, they cannot conduct electricity. That is basically the reason. One has free ions that are conductors of electricity. The other does not have those free conductors of electricity.
So right in front of me here I have sugar and salt. Now, something we've learned about is that a property of ionic compounds is that it's called an electrolyte. But what does that mean? Where does that come from? Well, let's explain that through this quick demo. So first thing is I have some just pure water here, and I'm going to fill both beakers up here so that you see it's just simple water. Now what I'm going to do is I'm going to take my salt. Remember, salt is made of sodium and chloride, a metal and a nonmetal, so that means that it's an ionic compound. Remember, the smallest piece of an ionic compound that still has its properties, we call that a formula unit, when one sodium and one chlorine ion come together. So the first thing I'm going to do is I'm going to take my salt, and I'm going to dump it in my water, and I'm going to take my glass stirring rod, and I'm going to dissolve that salt into the water. All right, I'll let that sit. Now I'm going to take my white sugar. I'm going to take it in my empty beaker that just has water in it, and I'm going to add that sugar to the water, and I'm going to stir. Now we're learning that ionic compounds, one of its properties is that we call them electrolytes. Now you've heard of electrolytes before, maybe like in Gatorade or sports drinks. Yes, we need different types of salts in our body when we're rehydrating ourselves because those ions can help with proper muscle function. Potassium's important, sodium's important, calcium's important. In fact, if you get into biochemistry more, you're going to learn more and more about why salts are important for the body, especially for athletes that are playing like all day, like a long tournament in volleyball or a super long cross-country run, or even if you're running a marathon. Those are super important. So what I have here is an apparatus. It has a light bulb with a positive and negative end, and what you can't see is that I have it plugged into the wall. The thing is that the light bulb isn't lighting up yet, okay? But there is electricity going through it, but nothing's completed the circuit for the light bulb to light up. So what I'm going to do is this. I'm going to place this light bulb inside the sugar water to start. If the sugar water conducts electricity, this light bulb will go on. So let's see if that happens. No, nothing happens. All right, so an explanation for that is sugar, which are covalent compounds, right? It's a molecule. When they dissolve in water, they really don't break apart into positive and negative ions, so therefore, they're not electrolytes. They don't conduct electricity. Again, think of the word electrolytes and electricity. There's a similarity there and a relationship. All right, now I've got my salt water. Let's see if we put this into the salt water, if it'll conduct electricity. And lo and behold, it does. Can you see that? When I put the light bulb electrodes in the salt water, it conducts electricity. So what's happening here? Well, when we dissolve the salt into the water, it started breaking up into its positive and negative ions. Positive sodium ions and negative chlorine ions, technically called chloride. By doing so, there are positive and negatives in this water, and when we put the electricity through it, the electricity can pass from one electrode to the other to complete the circuit so the light bulb can light up. So when we think about properties of ionic compounds, we say that they tend to be electrolytes, meaning they often can dissolve in water, and when they do, they conduct electricity. Unlike molecular compounds, which have covalent bonds. These guys don't break down enough, and they can't create that positive and negative end that can conduct electricity.